So in last class, we were discussing about the subnetting. Right? And we have taken the example that 16.20.20.0/24. Then we did the subnetting, right? So if I write down here, so 16.20.20.0 till 31, and 16.20.20.32 till 63, 16.20.20.64 till 95. Then next is 16.20.20.96 till 127. Then 16.20.20.128 to 159. 16.20.20.160 till 191. The next is 16.20.20.192 till 220. Then 16.20.20.224 till 255. Right? And we also understood the class 27. Right? If you recall the diagram, total we need 8 networks. So if I have this IP address, okay, you guys ready? Just a recap. Okay, if I write this IP address, if I write the same IP address once again, 16.20.20.0/24. This tells number of the bits where in network side. So number of the bits in the network side is 24. Then how many bits into the host side? 8. With the help of the 8, we get to the power 8 means total 256 IP address. Right? So if you remember the diagram, one network we need here, second here, third here, fourth here, fifth, sixth, 7, and 8. So if you divide 8, it would come 32, right? The total IP address you have 256, the big pool. In that 32, 32, 32, right? So this is what we have done, and the difference is 32. 0 to 31 means difference is 32, right? So after that we discuss about the, okay, this is the subnetting. Then we have discussed about the subnetting from host point of view. When we do the subnetting from host point of view, we always add 2. Before that, we have to see the branch or site where we have the maximum number of the hosts. And if you remember the last class, we had a site branch 3 where we had requirement of 30 and we add 2. So it would become total 32. To get the 32, we have to do the to the power 5. That 5 represents number of the bits in the host side. If 5 bits into the host side, then 27 bits into the network side. That is the 27, right? Then we all also understand in each subnet. In each subnet, if I write down the first subnet 16.20.20.0 1, 2, 3, 4, then 31. So this IP address is the network address or first IP address, and 16.20.20.31 is the last IP address, and this is called the broadcast IP address. And these two IP address cannot be assigned anywhere. There is no command on the router to assign this IP address. So this IP address is straightforward wastage of the IP address. That is why we add 2. If you take 30, so first IP is gone, last IP is gone, we'll get 28. But actually we have the requirement of 30. That is why we add plus 2, right? To achieve the requirement. And the first IP is the network address, last is the broadcast IP address in each subnet. So this is the first subnet /27. If I talk about this next subnet, that will start from 32. It will go till 63. So this would be your network address, and this would be your broadcast address. It is applicable in each subnet, right? Till now we have discussed. Okay. So this one is called subnet 0. In each, okay, this is a /27. If you have /28, /26, /25, right? Multiple possibilities that will come after this class. After this, so the first is called subnet 0, and the last is called not a very unique name, last subnet. First is called subnet 0, last is last subnet. So initially when the networking came, there was no command to utilize those IP addresses. The first subnet 0, and the last subnet. So it was straightforward wastage of the IP address. But in the real time, we cannot waste that much IP address. Nowadays, we have the shortage of the IP address. That is why IPv6 came into the market, right? And the IPv6 can cover beyond your imagination. We have that much IP address that can go beyond your imagination. You cannot count that. It's a more than trillion, billion, whatever, right? So the first is subnet 0, the second last is last subnet. But there were no command to use that. But later on, Cisco suggested a command. They started coming with the command that is called subnet 0, IP subnet 0. IP subnet 0. They introduced this command starting from 12.x image. That is the version. It's kind of Android. Nowadays we have the 11, 12, right? But probably if you remember, Jali, whatever, right? I don't remember those. So Cisco is also started. Now Cisco is having 16 series. 16.1.1, 16.2, 16.3. These are the images from the Cisco. So starting from 12, Cisco introduced this command. By default, it's coming with the router. You don't need to configure it. It's a default command. It is already built into that. So with the help of this command, they allowed us to use this IP address and this IP address both. Subnet 0 and last subnet. But still, there is no command to use the network address and broadcast address. Still, there is no command, right? So now we can use this. Now we can use those IP addresses, first subnet and last subnet. But in each subnet, the first IP address, the network address, and the last IP address is the broadcast IP address. Those cannot be used. There is no command to use that IP address. Clear? So starting from this is the command. under the config mode, we need to put the IP subnet 0. You guys can write down, but it's not required actually. By default, is coming with this router. So this is called subnet 0, and this is called last subnet. And okay, where is that? This one is mandatory. You need to understand this. First IP address and the last IP address, right? Then now starting from 1 to 30, these are your valid host IP address that you can assign to your router, PC, laptop, computer, edge devices. Hello? Okay, let's come. Now we understood the subnetting, right? You guys, right? You have to go to the keyboard videos. Okay, that is fine. Class A. Okay, if I write down the class A IP address, class A IP address. Class B, class C. Class A subnet mask is /8, class B /16, class C /24. If I write this into the subnet notation 255.0.0.0, 255.255.0.0, then 255.255.255.0. Now tell me the subnet mask for /22, /21, /28, /24. Tell me the subnet mask. Forget about the IP address. IP address could be anything. It could be class A, class B, class C. Anything which is with the any IP address with the default mask, that is called class full IP address. Any IP address without default mask. This is the default mask. Class A default mask /8, class B default mask /16, class C default mask /24. Any IP address without default mask classless IP address. Right? Now, if I want you to calculate the subnet mask for this, how would you calculate? If I have this /8, /16, /24, I can easily tell. Okay, /24 means 255.255.255.0. Right? /16, 255.255.0.0. Right? /8, 255.0.0.0. What about this guy? /22, /21, /28, /24. Right? So I will tell you 3 ways to calculate this thing. The last one is very interesting. First is find out the subnet mask for number or different number. Number, simply put number, because default one you know, right? So the first way is with higher value, lower value, and online method. Online method is very good. Don't have to remember anything. That is why I thought is very comfortable, right? Correct? So let's start. So before that, make a table. So the table is something this: to the power 0, to the power 1, to the power 2, to the power 3, 4, 5, 6, 7. This is 1, 2, 4, 8, 16, 32, 64, 120. The first one will come as it is, then plus 128 plus 64. It would come 192. Then plus it would come 224. Then plus 16. It would come 240 plus 248, 252, 254, then plus 257. So this table you have to remember. This is the first way, and there is another way. The second way is easy as compared to this, and the third way is most easy. You don't have to remember it. You just have to know how to open a browser, and you have to put your finger. You have to use your finger. So let's take the first example /22. Right. So if you remember, like total we have so this is clear. This is something no, right? Now /22. /22 means, see, till here you have 24, 32, 16 and 8. /22 comes between these guys. Forget about the slash. 22. 22 will come in between 16 and 24, right? So in that case, what we have to do? Now we know that /20 comes between 16 and 20. So we can do the subnetting. We can identify the subnet mask from the lower and the higher. So first of all, let's discuss with this /16, lower one, right? So 16 plus 6. If I add 2, if I add 6 there, I will get 6, 20, 22, 22, right? Now we have to see the value at the sixth position. Now after that we have to go under the table. So this is the first position, second, third, fourth, sixth, 7, 8. What is the value at the sixth position? No, that is the 4 means that numeric number, right? Sorry, binary value 252 decimal number 252, right? Correct. Now 252, we know that we get the 252, but how to write? If you understand, till /16 fixed, starting 8, then second 8, both are fixed. Changes are happening into the third octet. Changes are happening where? In between 16 and 24. So if changes is happening there, then definitely the 252 will come into third octet. because slash 22 that comes under the third octet. This is the first octet, second octet, third, and fourth. So changes are happening in which octet? Third octet. So here we have to write 252. Then rest all 0. Right? After that, till now, till here, 255 dot 255. These are fixed. Changes are happening into 250 third octet, and host bit will become the 0. Right? So 16 till here 16, we have to add 6 here. So these all gone. Starting from here 0 0 0 0 0 0. Rest all become 0. Right? Now tell me the subnet mask for slash 70. How to calculate first of all? What is the first way? Nearest one. So the 17 comes in between what? 16 and 24, right? So to get the 17, we had to add plus 1. So 16 plus 1, 17, right? And what is the value at the first position? Where is the table? What? 255 is the first one or last? First position. This is the first position, right? So 16 plus 1, 17, right? So till 16 is a fix. 255 dot 255 dot. What is that? 128 dot 0. Okay, tell me the next one. First, 128, right? 120. Okay. So, okay. Now tell me the subnet mask for slash 28. So how to calculate? This comes under which? Third and fourth. So the lower is 24. 24 plus 4. What is the value at the fourth position? 240. Right? 255 dot 255 dot 255 dot 240. Changes are happening in last octet, right? So the last one will get converted. Correct? Done? First way is clear? Any okay, let's take one more example. Tell me the subnet mask for slash 23. Changes are happening into the second and third octet, right? So 16 plus 7. What is the value at the seventh position? 254.0. Right? This one is clear? Okay, let's go for the next one. Next, higher value. Right? So let's take the same example, slash 21. Changes are happening into the third octet. Right? Third octet means 16 and 24. So last time in the previous one we have taken the 16. Now we will take the 24. So 24. So 16 and 24. So what I have to do? 24 minus 3 equal to 21. Right? These 3 number of the bits into the host side. This 3 represents number of the bits. So if I have 3 bits in the host side, then rest of it will be the network side, right? So, but not consider those things. So, with the help of the 3, you will get the 2 to the power 3 means 8. Total is what? 2 to the power 8, 256. 256 subtract 8. How much it would come? 6, 4, 2. No, it's wrong something. This is 8, right? So here 248, or 256, 8, 248. Correct? And the changes are happening into the which octet? Third octet, right? So starting 2 octet, 255 dot 255 dot 248 dot 0 slash 21. What we have is slash 21 here. Okay, slash 21 we haven't calculated. No problem. Okay, let's calculate the slash 21 via first method. Slash 21 is 16 plus 5, right? So this would be the fixed 255 dot 255. Then what is the value as the fifth position? 248, 248 dot 0. And this is also same. Correct? Now calculate for slash 29. 24, 32, right? 32 subtract with the how much? 3, 29. So this is 29 to the power 3 means 8. And total is 256. Subtract 8, 248. So for this subnet mask would be 255 dot 255 dot 255 dot 240. Clear? Third one is very simple. One not don't have to put our right. Done? Okay, let's come to the online method. It's very easy. You don't have to do much. What you have to do? You have to open a Google. Then you have to put a subnet. Automatically it will help you. Automatically it will come subnet calculator. No need to put anything. Enter. At least you have to put your finger there. Right? You can use any tab. You can use any one. Multiples are there. Let's use the first one. The only thing is here you have to put the IP address. Correct? That is also not required. We'll come to know. So let's take the first example. Slash 21, right? We have said 225.225.248.0 slash 22. What is the slash 22? 255.255.252.0. Very simple, right? Not need to remember everything. Correct? So if you get any IP address, let's suppose I have the IP address 16.20.20.0. I have the slash what was that? Slash 27 in our example, right? Let's calculate. At the end, you will get all 8 of the possible slash 27 networks for 16.20.20.0. The first is starting from 0, it is going till 31. If you see, 31 is the broadcast IP address, right? And the first 0.0 is the network address, and the valid or usable host range is starting from 1 to 30, right? And it is applicable for all the outputs. The next is 33 to 62, 65 to 94, 97 to 128, then 129 to 158, 161 to 190, 193 to 224, 225 to 254, and the 255 is the broadcast address. Right? Very simple way to find out the subnet mask, right? So any doubt till here? All clear? If that is clear, then let's move further. Class of the IP address, that is already you guys know. First is classful, second is classless. If you have classless or classful, it doesn't mean that if you have the classless, then you will get the internet. If you have the classless, you will not get the internet. Whatever IP address you have, if you connect with the 5G network, you will get the 20 times speed compared to the 4G, right? That's what they are claiming, but hardware is not captured. The launch, right? Government is actually classful IP address with the default mask, right? Class A default mask is /8, class B /16, class C /27, 24. These are the classful IP address. Any IP address with the default mask, that is classful IP address, and the classless IP address not with the default mask, classless IP address. Clear? Let's come to the our diagram once again. So this is head office, branch 1, branch 2, branch 3, branch 4. Here we have the requirement of 20 hosts, 30 hosts, 10 hosts, and let's suppose 16 hosts. Right? So I had the IP address 16.20.20.0/24. Correct? So here total I need the 8 networks, and we did the subnetting on that basis 16.20.20.0/27, then 20.64, sorry, not 64, 33 slash 32 slash 27, then 64 slash 27, then what was the next here? 96, 20.96 slash 27, then 128 20.0 slash 27, then 160 slash 27, 192.20.192 slash 27, then 224. This is that IP. This is the IP address, right? So what I'm doing, I'm taking one subnet and assigning to the particular interface. Now, what is the problem? So in this particular range, I will have the IP address starting from 0 till 31. 0 is the network address. This is the broadcast address. And starting 1 to 30, these are the valid. Correct? We'll assign the IP address from the valid IP address. So let's suppose we are assigning the .1 here and .2 here. So .1 plus .2 and the plus network address plus broadcast address. Total 4. Correct? In the networking, a subnet, any subnet which is used at a place cannot be used at the other place. If you assign any subnet in the network, that same subnet cannot use at the other place. There is some advanced thing, right? Don't consider those things. From the CCNA point of view, consider that if you used one subnet at a place, that subnet cannot be used anywhere into the network, right? And how many IP addresses we have here? 30. And we are using 4. Total IP address 30. Used 4. Then how many is that? 28? 26, right? In that also, we know that the network address and the broadcast address state forward wastage of the IP address. So forget about those things. So that is the universal fact. You cannot avoid those things. So straightforward, right? Between the headquarter and branch office, we need 2 IP address. We need 2 IP address, right? Total is valid host IP address is 30. The network address and the broadcast IP address, those are not valid IP address. So forget about that. So total valid IP address we need 2. And total we have 30. So then how many will you get here? 28. Now remember the statement once again. If you use a subnet at a place into the network, it cannot be used at any other place into the network. So if I use this subnet, I cannot use this subnet anywhere. I cannot use that. If that is the case, that means is this 24 IP address, 28 IP address is the straightforward wastage of the IP. If I am saying a subnet cannot be used at any place, anywhere into the network. So in that subnet, I am using only 2 IP addresses. And rest all IP addresses are wastage of the IP address. Similarly, here also I need the 2 IP address. One is here, one is here, one is here, one is here, another is here, another is here. So total how many have? How many? 4. One is from here, one is from here, one is from here, and one is from here. So 28 into 4. It would come, right? Right, huh? Okay. So straightforward 112 IP address, wastage of the IP. In the real time, you cannot waste that number. In real time, you cannot do that. So till now, the way we are discussing, that is the FLSM, fixed length subnet mask. Why? Because in that when we have the /24, we have done the subnetting, and each subnet we have the fixed number of the IP address. 30, 30. Difference is 32. The first is network address, last is the broadcast address, IP address. The valid usable IP address is 30, right? So in each block we have 30 IP address, right? It's a fixed actually. So this approach is called fixed length subnet mask. FL So we cannot waste that much IP address. Then what is the solution? Solution is, this is the problem. This is the problem into the subnetting, and this comes under the fixed length subnet mask. So the solution is VLSM, variable length subnet mask. Correct? Now let's understand what is this, right? So what I'm going to do here, okay, let's pick the first subnet. How many IP addresses we have here? 30. Correct. Let's pick the one subnet and let's do the subnetting once again. Right. So here in between the branch office and headquarter, how many IP addresses we need here? I need one IP address here, one IP address here. Right. So total two IP address. That means total two valid IP address. And in each subnet, the first IP address is the network address and the last IP address is the broadcast IP address. So if you go with the two for subnetting, then at the end we'll get the 0 because the two IP address will go, one will use the network address and then is the broadcast IP address. So when we do the subnetting from host point of view, we always add +2. So the requirement is 2. Now we'll add +2. Why? Because the first IP address is network address, last is broadcast IP address. To avoid the shortage of the IP address, we'll add +2. Right? So the requirement is +2. Sorry, requirement is 2. I need 2 IP address. But when we do the subnetting from host point of view, we will add 2 to 4. Right? Now this 4. Total we have 30. Right? Valid IP address. That is starting from 0 to 31. So total IP address, including the network address and broadcast IP address, 32. So you can understand from two point of view. Okay, first is total is 32. I need 8. I need 4. Total is 32. I need the total. How many network we need? If you come here, one is here, another. Total 4 networks we need, where we have the requirement of the 4 IP address. Right? So if you divide 32 with the 4, you will get 8. Correct? This is the first way. Second way to understand this 8, 4, to write down this 4 into the binary format, we have to write 2 to the power 2, 4. This 2 takes the number of the bits. Number of bits in host. Correct? Total is what? 32. 2 bit will go into the host side. Then how many bits we have in the network side? 30, right? So total number of the bits into the network side is 30. That means slash 30. This is clear. Now I need to write the IP address here. So to write down the IP address, we have to make a block of 4 IP address because we need 2 IP address. Out of that, actually we need 2 IP address, but in each subnet we have one network address, another is broadcast address. Right? Those are the IP address that we cannot assign anywhere. Right? So if I divide this thing 16.20.20.0/27. 16.20.20.0 till 3. I can write like that. First full. Second is 16.20.20.4 to 7. 16.20.20.8 till 11. 16.20.20.12 to 15. 16.20.20.16 to 19, right? Correct now? 16.20.20.20 to 23. Then 16.20.20.24 to 27. Then 16.20.20.28 to 31. I can write like that, right? And here is 30. This came from here. So now if you understand this from the reverse point of view, if you get IP address something like this, 16.20.20.0/30. This tells the number of the bits into the network side. Host 2. With the help of the host to the power 2 means totally we will get the 4. 4 IP address. What is the first IP address? 0, 1, 2, 3. In each subnet, the first IP address is the network address, the last is broadcast IP address. This cannot be used anywhere. So the valid IP address .1 and .2. These we can assign to the router. Correct? Now let's come to the diagram once again. Okay, so here I will assign the first IP pool 16.20.20.0/30. On the in between that 16.20.20.4/30. 16.20.20.8/30. Here 16.20.20.12/30. So if I consider these things, so the first is 0, 1, 2, 3. This is the network address. This is the broadcast IP address. This I cannot assign. So what I have to assign here? .1, .2. Similarly, 4, 5, 6, 7. 4 and 7 network address and broadcast IP address. Then I have to assign the .5 and .6. Here .9 and .10. In between that .11 and .10. No, wrong. 8.8 and dot 9, right? Then dot dot what is it? 67.8.9, correct? The 10 is gone. Dot 11 and dot 12. Where is that something? This one will go to the first, second. Here we'll get the dot 5 and dot 6. That here we'll get the dot 10 and dot 9 and dot 10. And here we'll get dot 13 and dot 14. Okay, so let's correct it. Dot 13, 14, dot 9 and dot 10. Clear? Now in each subnet, if you see, total we have the 4 IP address. One is network address, last is broadcast IP address. We have assigned 2 IP address. In that subnet, I don't have any IP address. That means it's not wasted of the IP address. Similarly, we have done from branch to branch here. Correct? Right. Let's suppose in future you have the requirement to add one more branch of this case. Branch 5. In that case, will you go to your manager and ask, give me the new IP address? No. Why? Because you already have the subnet. You already have the free subnet in your pool. We have used this, but this one. 4 free subnets. I can assign this subnet. I can assign dot 17 and dot 18 IP address. Correct? After that, this is the advantage. This is the first advantage. Second advantage coming in. If you see this IP address, we have taken this pool, right? And in LAN, we have assigned from the IP address. The range is, where is that? Okay, 128, 160, 192, 224. 128. This is going to LAN. These two again LAN. What about these two guys? And this guy. This thing and this thing. Again, these are free. Because this IP address /27 starting from 32 to 63 and 64 to 95 and 64 to 127. It was going between head office and branch 2, branch 3 and branch 4. But in branch 2, branch 3, branch 4, we have assigned the IP address from here /30 pool. So this will be free. So this IP address is free. 30 IP address here, 30 IP address here, and 30 IP address here. That is from /27 pool and 4 subnets from /30. 3 subnets from /27 and 4 subnets from /23 here. This is also free, this is also free, this is also free, this is also free, because till now we have used this one. So this is the beauty of the VLSM. When you do the subnetting with the help of the VLSM, you will be able to assign the appropriate number of the IP address. Right? And when we do the subnetting from this point of view, we'll also get the IP address. Use IP address, use free IP address. In future, if we have the branch deployment here, diagram. In future, what I can do, I can assign, okay, dot, this is dot 13 and dot 14, dot 17 and dot 18. I can assign the next pool, right? Let's suppose we have here, we have the requirement of total 30 hosts. 30 hosts. Then what I can do, I can take 32, 32. Two pool of the slash notation. Means which pool? These two are free. Here I have the 30 IP address. Here also I have the 30 IP address. Valid IP address. If I add those things, we'll get the 60. So instead of this, I can assign the entire pool to my next branch of this. Right? I don't have to go to my senior authority manager to get the IP address because I already have the IP address to assign to the next branch. This is the advantage of the BLSM. Into the FLSM, fixed length subnet mask, you will have the wastage of the IP address because in the networking, a subnet is used at the place, it cannot be used at other place into the network. If that is the case, then if I use this subnet, I cannot use this subnet at the other place. So it's a straightforward wastage of the IP address. To avoid this thing, we have the solution called VLSM, variable length subnet mask. So with the help of the variable length subnet mask, we can further do the subnetting as per the requirement. Correct? Clear? Host pointer. If you remember subnetting first class, we have discussed the subnetting from host point of view. And network point of view. Until now, whenever we have done the subnetting, we count the number of the host, right? So that is the subnetting from host point of view. Network point of view, subnetting is very simple actually, but this is small difference, right? After that, it's almost equal to the host point of view. So let's come for the next one. Network point of view. Subnetting from network point of view. Subnetting. Imagine the same diagram. What is the diagram? How many networks we need here? 1, 2, 3, 4, 5, 6, 7, 8. Right? And then we also had the host, like let's suppose 16, 30, 12, 20. In the host point of view, we have taken the maximum number of the hosts at the branch office. But this time we'll not consider those things. This time we'll see the total number of the networks. Correct? So total number of networks, remove it. This is not required. Total number of networks. How many networks we need? Total 8. So the number of the network is 8 in this diagram. Correct? Now this number of the 8, right? Last time in the host point of view, we were moving the host bit into the network side. But this time we'll move the network bit into the host side. So let's take the same sub IP address 20.0/24. Correct? In that network bit is 24, host bit is 8. The slash 24 means total number of the network bits into the network side. And total, if I have the 24 into the network side, then 8 bit will be into the host side. Correct? So total number of the network to get the to get the 8 network, what we have to do? This is the decimal number. If I want to achieve into the binary, so we have to write to the power 3, 8. Correct? Now this 3, this is again number of the bits into the both sides. Correct? This time we are doing the subnetting from network point of view. So we have to move this 3 bit from network side to host side. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 0, 0, 0. Right? This is 8, 8, 8, and again 8. So this is a slash 24. And these all network bits 1 and host will become the 0. Now I am saying move the 3 bits. So what you have to do, we have to move these 3 bits where network side. So if I move 3 bits, so total we have 24 plus 3, 27. Last time we were discussing, we were considering the 30 here, then we were adding plus 2. Why? Because we were doing the subnetting from host point of view. This time we are doing the subnetting from network point of view. We don't have to consider this one. We just have to consider the network. Then slash 27. If you get the slash 27, after this, all the process is same. Slash 27 means it will start from 0 to slash 27 means 27 bits into the network side, then host bit is 5. With the help of the 5, we'll get total 235. Sorry, 32. So it will start from 0 to 31, then 32 to 63, then 64 to 95, then 96 to 128. It will go till 252. Right? So let's suppose I have a headquarter here. At headquarter, I have a router. This headquarter is connected with the branch 1 and branch 2. And the LAN subnet. Here I have the IP address 16.20.20.0/27. Here 16.20.20.65/27. Here 16.20.20.28/27. Right? Now, when we configure any protocol, in between headquarter and branch 1 and branch 2, so branch 1 will advertise its own route and branch 2 will also advertise its own route. So here basically 2 cases. When we have the class full IP address, at that time subnet will not go into the update. Class full means /8/16/22. But when we have the classless, subnet will go into the update. In the coming classes, we'll come to know about that. RIP version 1 is the class full routing protocol. That means it doesn't support the classless. Similarly, IGRP is also class full routing protocol. It doesn't support the classless. In RIP, only version 1. Version 2, starting from version 2, that is capable to support the classless. Classless means along with the update, along with the IP address, it will also send the subnet mask. So here, in all case, we have the classless because class of the IP address is a class A IP address. This is the what is the class of this IP address? Class A, na? Class A, the default mask is class 8, but what we have here? Class 27, that means it's a class less IP address. Right. Now, when it comes to headquarter in the routing table, it will come something like this. It's a headquarter. Let's suppose this is 0/0 interface, git 0/0, and this is git 0/1. Right? So this update 16.20.20.0/27 via 0/0 and 16.20.20.28/27 via 0/1 and 16.20.20.65/27 via 0/1. This is what I get. Right? Now, at the head office, there is a person whose IP address is 192.168.10.10. And here also I have a person. Here also I have a person. Correct? Now he wants to communicate with the IP address. This is source IP. Destination IP is 16.20.20. Let's suppose 20. Correct? This is the destination IP address. And okay, let's make it in the format. How fine? Source IP, destination IP, right? This is source IP, this is destination IP. When the person A wants to have a communication with this IP address, the packet will come here on the router. As soon as router receives the packet, router will open a layer 3 header. In the layer 3 header, it will see and it will go to the routing table. And it will ask, can you help me to reach to 16.20.20.20 IP address. Router will look up the routing table. Look up the routing table, look up the routing table, and look up the routing. In that case, router will get confused. Why? If you see this thing, /27, 16.20.20.0/27 and 16.20.20.28/27. What is the range for this? Total, how many IP addresses we have here? 32. It will start from 0. It will go till 31. What about here? It will start from 0. It will go till 31. Both are same, right? The router will forward here and again here. Let's suppose both are same. Here also I have the .20 and here also I have .20. Router will send one packet here, one packet here. Do you think actual communication is happening? Let's suppose in the class I have a person whose name is same. If I call that person, both guys will reply. But I want to communicate with a single person. but both guys are replying. So this is the problem with the subnetting. This is the problem when we use the same subnet at the other place. In that case, suboptimal path will get created. Suboptimal path. The symbol for this, if you see this kind of behavior, reply dot means reply, then again drop reply. This is the reply. This is the ping reply. This is the drop. If you get reply, then drop, reply and drop, reply and drop. So this is the behavior of the suboptimal path. If you get this kind of response into the ping, that means it's a suboptimal path. Suboptimal path means a same subnet is being used somewhere in the. That is the problem. Router will get confused actually whether I have to forward to branch 1 or branch 2 because both are having same subnet. If I call anyone and then that same name, multiple people are there, right? Then even I will get confused whether I am calling to this guy, and that person will also get confused whether he is calling to me or someone else. If I call ABC, now 4 people raising a hand. Okay, I am also ABC. I am also ABC. Now who will reply to me? Who is going to reply? Right? So this is the problem with the suboptimal path. This is the problem with the subnet when we use the same subnet at the other place into the same network. In that case, we'll get the suboptimal path, right?